Hello and warm welcome to Func Prog Sweden. Func Prog Sweden is the meetup that is dedicated to spreading functional programming. We have been running this meetup since January 2020, that is more than 5 years. We have had over 100 presentations on different FP topics. We currently have over 25,000 subscribers on YouTube and a little bit more than 2,000 members on Meetup. And today we will start in a different way. You might ask why, and because today we are launching the Func Prog podcast. The Func Prog podcast will, as the name implies, be a podcast where we will interview different persons in the FP community about functional programming. The host of the Func Prog podcast is Christopher Ekeroth. And as part of the launch of the Func Prog podcast, we will do an interview with Christopher. Warm welcome, Christopher, to Func Prog Sweden.
Oh, thank you, Magnus. Thank you. It's not my first time here, but I'm always happy to be on the show.
Welcome, welcome. For those who don't know you yet, who is Christopher and how came you into FP?
Oh, that's a good question. My name is Christopher. I've been a software developer professionally for almost 15 years now. It feels like a really long time. I also run a company called Functional Software, which is a staffing agency that specializes in functional programming. But the reason I got into functional programming in the first place, I think, were those essays that Paul Graham wrote about Common Lisp. I think that was around like 2004, 2005 or something. And the way he was talking about it, like how cool Lisp was, etc., made me really excited and curious. I was like, oh, I have to figure out what this thing is. So I got my copy of Structure and Interpretation of Computer Programs, and I think I got through the first chapter or something before I gave up. FP really stuck with me. I also had this moment I remember when I first saw Haskell, which was like in a textbook at university for a course that I didn't take. But I was curious, so I thought it looked interesting. I got the textbook anyway, and I was just blown away by how terse and compact it was. So I don't know I've been really into functional programming ever since.
Nice. So, what made you want to start a podcast in functional programming?
Well, I mean, I really like podcasts for one, and I mean there are a bunch of functional programming podcasts out there already. Yep. But honestly, I think there's always room for one more.
Yeah. What can the listeners expect from the podcast?
So I kind of want it to be very very relaxed, very free form. And the format is I bring a guest on each episode, and we talk about different aspects of functional programming. So each episode has a theme, whatever that person is an expert in. So, and I don't really I think it's quite fashionable with this long form podcasts now, and I didn't really intend for it to be long form, but the first one is 1 hour and 50 minutes, so I guess that's what it is now. It's I don't want to interrupt people when they're talking about interesting stuff. So
yeah. Sounds nice. So I mean, you already answered this question more or less, or partly at least. Will the podcast focus on interviews, or will you deep dive into technical stuff, or will there be a mix of both?
Yeah, a little bit of everything, I would say. But like I mentioned earlier, if I bring people on, I think the thing is I what really drives me, other than like, you know, liking functional programming and thinking that there should be more functional programming podcasts, is that I'm curious about a bunch of different topics. So my thinking so far is like, oh, I really want to know about this, and who can I ask? And then I invite them on the podcast. So I mean, some people, they ask ChatGPT. I invite someone to record 2 hours of audio, and then I have them answer my questions. Yeah, that's how I work anyway.
Interesting. Will there be any specific niche or angle you want to go for? Or is it just like, I'm interested in this at the moment, I will go for type theory, I will go for something else?
Yeah, it's gonna be more like that. Like more, I think it is going to be driven a lot about, like, you know, I mean, partially who wants to come on the podcast. Like, you know, if you want to come on the podcast, like, you know, just reach out. You can find me on LinkedIn. You can find me on Twitter.
Mm,
Like, you know, you can talk. Yeah, I'm in the Func Prog Discord as well.
for sure.
But yeah, like you said, I mean, it's mostly going to be driven by things I am curious about at the moment, because I think that's, you know, the way you get the best material.
Mm,
But also, secondly, I think like I also want to explore a bit about, like, you know, how people actually use functional programming in real world scenarios. And that's something I consciously trying to bring in as well. Like, you know, how are you using functional programming in production? Like, you know, how does that
mm,
work? What are the pros and cons, etc.? Because I think there's a bit of a hole in the market there. I'm also super into like the theoretical stuff. So there's going to be a bunch of that as well. But I want to have a nice, you know, a nice mix, a bit of everything.
yeah. Functional programming is somewhat of a niche, unfortunately. Yet, um, why do you still think it matters?
Well, for me personally, and I've kind of bet the farm on this as well by starting a company around this. So, but I honestly believe that, you know, the future of functional programming is the future of programming,
Mm,
pretty much. And we have kind of started seeing this already, where, like, you know, all of the mainstream languages today, I mean, you couldn't really call them functional programming languages unless you're being very generous, but all of them have like sucked up this, like, have subsumed the functional programming concepts and the philosophy into them. So, like, you know, in a way, it's already happened. But I think we're going to see, like, you know, the next generation of programming languages is probably going to be functional, I
mm,
think.
yeah. How would you say the FP community has changed over the past few years?
I think that's very interesting. Like, you know, like I said, when I really got into functional programming, a lot of it was about Lisp. Like, people were really talking about, like, you know, like Common Lisp was this hot new thing. I also remember, like, Douglas Crockford's book about what was it called? Like, well, something about JavaScript. Oh yeah, JavaScript, the good parts. And there was this joke where you had, like, you know, the JavaScript Bible was like this thick, like a phone book, and then the Douglas book was like less than 100 pages or something. Like, you know, it looked really small next to, like, the complete JavaScript book. But yeah, that joke never got old, by the way. But I think we have moved towards more of a focus on, like, static typing,
Mm,
like stronger type systems. And I think there was a huge vibe shift around the time when TypeScript came around.
mm,
Because I think before there had been this, like, false dichotomy. People were really sick, I think, about of static typing. But it wasn't really because static typing was bad, but it had got a bad reputation because the type systems thus far had been really underpowered. So people thought that they really disliked static typing, when in fact they disliked, like, weak type systems that
mm,
got in the way and didn't help.
mm,
But then TypeScript came along, and it's sort of like, you know, it had almost like, well, I mean, it had overnight success, and it only took like 20 years or something. I don't know. I know TypeScript had been in development for a really long time at Microsoft Labs, but or like at the Microsoft Research, or whoever came up with it. But I think it was really like, proof that like types can actually help you. It helps you reason about large and complex applications. So I don't know. I think we're going to see a lot more of that in the future, and I think it cues very well into Elisabeth's talk later. I suspect about like dependent types.
About to say that. What do you think is the future of functional programming?
Well, other than going mainstream, I think again, like I think we are going to see even stronger type systems. Whether that's like dependent types or something else, I don't know. I think liquid types, like in liquid Haskell, might also be like a promising avenue. It's hard to say, but I think it's going to be something like that. And also, I think it's going to be really hard to bootstrap new languages nowadays. So I think whatever comes next, I predict will be built on top of like maybe like Clojure or F#, like you're sort of building on top of something else, like the JVM or .NET or something. Like there's the ecosystems of today are just, they are way too big to sort of start from scratch. So I really suspect that like the next big thing, it's going to be built on top of something else.
Yeah. Where can we find the podcast? Except for the YouTube channel, I think anyone that's watching this will know that you can find it here. But where else?
Maybe you have seen it already. But the like on all major podcasting platforms, it's on Spotify, it's on Apple Podcasts, and there are a bunch of other players. Most of them syndicate from there, so I think it should be available anywhere, and it's available today.
Yes, I maybe forgot to mention that, but it's available today. It's available both here on the YouTube channel and on Spotify, Apple Podcast, and wherever you can find your podcasts. How often will you release?
So the target is to have like every other week. So I when I put it on Apple Podcast, it asked me like how often will you release, and it it only had like this like 4 different options. So I was like, oh, okay, bi-weekly, I guess. So now it is like I've committed to a release schedule.
You're committed to every second week then, so we'll expect that.
Yes. So like keep an eye on your podcast player every other Wednesday.
Cool. Thank you very much, Christopher, and I hope everyone will enjoy the podcast, and that the podcast itself will also continue to spread functional programming.
Yes, and like like they say, like the kids say nowadays, don't forget to like and subscribe.
Exactly. Thank you very much. Thank you. And now we head over to our usual schedule. So today's agenda. First, an intro by me. You've seen that. Then we go over to Boost Your Command Line Application with Potions by Eric Torreborre. Then Dependent Types Are Everywhere by Elisabeth Stenholm. And then in the end, there will be post-show chat for those who want to ask more elaborate questions on the presentations, or just want to find the links, etc. We'll post them, and you can ask more elaborate questions in the Discord server. First, I would like to thank Beat, our video sponsor of Func Prog Sweden since the start, 2020. Thank you very much, Beat. If you want to know more about Beat, you should check them up on their webpage, adabeat.com, or on social media. Then we'll run the schedule for the coming meetups. Today, 16th of April, we're running one meetup. Next meetup will be 20th of May. Then we haven't decided on a date in June. And of course, we'll run a meetup in August, but also a little surprise in the end. 15th of October, we will run something called Func Prog Conf. It will be a half-day conference on functional programming. You can find the webpage at funcprogconf.com. And we will announce speakers, program, etc. So be sure to check it out. If you want to support Func Prog Sweden, head over to MeetUp, subscribe, head over to YouTube, subscribe, follow, etc. Also, make sure to join our Discord server. There you can ask more questions, and also more elaborate questions to the people that are presenting. Exactly. So if you have questions online, please use the YouTube or the Discord to ask them. With that, let's start. Welcome, Eric, to Func Prog Sweden.
Hi.
Hi,
everyone.
Eric, and warm welcome to Func Prog Sweden.
Thank you.
Yeah, you're welcome. We are.
Yeah.
Yeah. You can hit it away,
start.
Eric. That's it.
Can you see my slides?
We see your slides perfectly
now you
well.
can. Okay, that's fantastic. Yeah, so today I'm very happy to talk to you about a functional programming language called Unison, which is a functional programming language that I love, and how I use Unison to implement a command line parsing library called Potions. And if you wonder about the name, it's a not so clever anagram. Potions is just an anagram of options. That's how it came to be. So last year I was implementing oops, I'm trying to find a clicker. Yes, I was implementing some application using Unison, and I found myself wanting to pass arguments on the command line. And Unison is in a way, is a fairly new programming language, so it doesn't have the whole ecosystem. And it's kind of funny that Christopher said that the next big thing will have to be built on something that exists, because Unison is kind of starting from scratch, but it starts from scratch for very good reasons. And we'll talk a bit about that. So yeah, I thought to myself, okay, how hard can it be to build a command line parsing library? And it turned out to be more complicated than what I anticipated, because there's no real standard for those kinds of libraries and how you deal with arguments on the command line. So if we have a look, for example, even just the naming of things. So in Rust, we talk about passing args in general. In Haskell, the naming is a bit more, there are more differences between the names. You have flags, options, arguments, switch. And in Java, it's either people are calling this an option or a parameter, the thing you pass on the command line. So no real standard. Now, if we have a look at the features that such library can offer, there are tons of different features, and there's not a real standard set of features. So for example, when you pass a value by giving it a name, like -- name space value, some libraries also allow you to pass name equal value, for example. So this is something that I supported because it was not hard to support, but not all libraries propose this. And we'll see some in more detail, one of the features that are provided by this library, and that the red crosses are things that could be supported, but that I don't support yet. Now, if we turn to the help and how the help is displayed, here again, we can see many differences between various libraries. So the help is, of course, a very important part of this kind of library. You have all sorts of options that they have different meanings, and you want to know what they mean. So this is one example of a command line application that's using Rust. There's CP, I think, is the one from just mancp. If you run JQ -H, you will see, for example, one thing that does not appear in other help display. You have precise examples on how to use a command. Then if you run the Snowflake, so Snowflake is a database. If you run the snow command, you will see some help with colors, for example, and nice sections and different typography and boxes. So now people are trying to make even nicer help displays. And I think this one is using Python under the hood. So yeah, no real standard. So I got to choose things that I liked. So let's start with showing you a small example of what you can do with the library. So I want to implement a simple command here that's just going to copy one file from one file path to another file path. And so this is the command I want to parse. Those are the things I want to parse. The thing before the blue box is related to how you run programs in Unison. So that's not really important. So when I run my program with those arguments, I'm first displaying, executing the command is just displaying, okay, I'm copying the secrets file to the stolen file. And I can also run the command by passing the --help flag. And in that case, there's all the help for the command with description of the command, description for all the arguments and so on. And as you can see, I like colors, so it's all colored. So, okay, now what about Unison? Because I use Unison to implement this library. So Unison is a functional programming language, which is very close to Haskell. If you know Haskell, you will be really at home with Unison because it has strong static types that are very reminiscent to Haskell, but it has strict evaluation. It doesn't have any type classes, which is a bit surprising at first. And it doesn't have things like macros or language features. In some ways, it's a very simple functional programming language, very, very bare bones. But it also relies on something that's very new. It relies on using immutable code. So all the code that you produce goes to a database. Each function is hashed. The hash of the function is actually the internal identifier of that function. So that never changes. And that has some very nice and very important properties. When you deploy code, for example, if you ever deploy like a variation or an update of your function, any code that was depending on the older function will never break because they will not depend on the function name. They will depend on the function hash. So this is a very profound property that has impacts on not only on deployment, but also on how we develop the software. Again, just the fact that it is stored in a database has some important repercussions on how we develop with Unison. And it has one superpower. So I said it's a bare bones functional programming language, but it has an effect system. So there are a few languages that support like a real effect system, like Coca, for example, and Unison is one of those. And we'll see how to use this effect system to implement the library. So again, if you don't know Unison, I'm just having a quick look at the syntax. So it's very Haskell-like. You can have a type signature showing you the type of the arguments you want to pass. You can use pattern matching. So you can match an option of a person and extract parts of your data types. There's a shortcut. If you don't want to name the parameter P, you can use cases to do your case analysis, very much like lambda case in Haskell. There are a bunch of literals in the language for lists, strings, tuples. There's also a pipe operator that is frequently used in the code, a bit like F#. And then if you want to declare a data type, you give it a name, and then you can declare fields for your data type. So pretty simple. But now there's this new thing, which is the effect system. And in Unison, this is called abilities. And to explain what an ability is, I'm going to make an analogy with the reader monad in Haskell. So if you know a bit of functional programming, you know that there's a way to structure your program so that you can ask for an environment that will be passed later. You can ask for a given value. So this is exactly what we are doing here. The reader ability gives you the opportunity to ask for a value, but this value will be tagged with the effect. It's a computation now. It's just not a pure value. And you can use it to implement add, where you can add a value n to something that you ask that will be provided later. But then the results will be depending on the fact that you read a value from the environment. So this is why we have this annotation in curly braces. And then how to implement this effect. To implement this effect later on, we use the handler. So you handle a computation with different cases. The first case is there's no effect. No one used the ask function. Then you return a value. But if someone called the ask function, then you are going to provide the R value, so to a continuation K. So K is a continuation for the rest of your program. So the first time we call ask in add, the interpreter will go up to the nearest handler, says, oh, I have a value R to provide, and it will call the rest of the program with R to continue the rest of the program. And if there are other effects, and this is the case here because we ask again, then we run reader one more time. So recursively, we run the effect until there's nothing left to run. So if we use this run reader handler on top of add 3, we run reader with an initial value of 2. We ask one time, 3 plus 2 is 5, and we ask then a second time, 5 plus 2 is 7. And what you see here is actually something called the watch in Unison. So if you put an expression with a greater than sign inside your code, it will automatically evaluate when you modify your code, which is actually also nice in terms of development environment, because that means you have a REPL integrated inside your code, which is a very cool thing to have. So Unison comes up with all sorts of abilities already bundled with the language. So you have abilities to have exceptional behavior, like abort an operation, throw an exception that has a specific type, or just throw a generic exception. There's a state ability, a bit like the state monad, where you can put and get a value. It's called store. You can do IO with an IO ability. You can get random values to generate data for your test, for example. There's a non-deterministic ability, because the continuation we use, the K continuation, doesn't have to be invoked just once. So you can invoke it with different values and then collect all the results corresponding to all the invocations, which is a very powerful thing to use. You can stream values, create streams of values using abilities. And also Unison has a very strong offering for deploying services in the cloud. So you can use this to the remote ability to deploy things in the cloud. And yeah, this is another topic, but this is very cool. And this is also modeled as an ability in Unison. So now let's have a look at the library. What we want is to parse strings coming from the command line and make like well-typed object with a source, a destination, and maybe a Boolean telling us if we want to force the copy or not. And in the library, you will declare a parser for those things like this. So we want to produce a copy object with a parser effect, because that thing will come from doing some parsing. And we start by declaring that we want a copy command. We can give some help. So there's a short help and there's a doc help. So curly brace is actually documentation as a first class object. So Unison as a first class documentation object, which is really cool, because when you document your functions, you can put some code in there. The code will be compiled. You can even execute some code, so you can have executable examples in your documentation. That's very nice. And that can also produce some markdown and so some very nice HTML pages. So this is something that I leveraged in the library to be able to get some rich help. And then you have 3 options: copy, source, destination, and force. And those are 3 separate parsers that we eventually use to actually do the parsing. So the last line is actually invoking 3 different parsers to collect the source, collect the destination, and collect the force Boolean. And once we do this, we have a full copy object. So now if we drill a bit about those declarations, like an option, so you declare the name, the short name. So $S is for a character. It's not a string, it's just a single character. The help, and then there are a bunch of declarations under file path, which come from another function with a different effect. We'll talk about that, where you describe how you want to decode values from the command line, how to document them with the type, how to display them. And you can also provide examples for those values. And that's useful to produce the help. And we'll see also how it's important to have those examples later. Most of the time, you don't have to do this yourself, because for most of the data types coming with the base library, they are implemented and supported inside the potions library, so you don't have to deal with this. There's even something that is pretty nice, which is a format. So most of the time, because we pass strings, it's also nice sometimes to be able to specify exactly which format we expect to have for those strings. So this is also documented. Of course, you can pass your own values on the command line, your own types. So if you have your own type like this, you can use the value DSL, which is an ability to use the functions like decoder, display with, give an example, and then that thing will be already usable on the command line. And there are also a bunch of combinators, which means that if you know how to parse a value of type product ID, you can know it's easy to make a parser for a list of product IDs by using the list of combinator. And if you know how to parse something of type product ID, but that thing should be actually optional, maybe it's not passed on the command line and you don't care, it's just none, then there's the optional combinator that will make it an optional value. And as you can see in the type signature, you start from something that produces a product ID and then it returns an optional of product ID. So eventually you can use different primitives to produce, to declare option parsers. So for options, things that have a name, for flags, things that don't have a name, and for arguments, things that are just positional. And there are variations for all of this. So for options, you can specify, and flags, you can specify different names, which can be useful if you have aliases to an option. So let's say you're not satisfied with the original name that you gave, dest, you want to change it to destination, you can just create an alias for this. There's a shortcut for flags, which is call it, if your type, the type that you're parsing is a Boolean, you can just call that a switch. And for arguments, you can also specify things like the exact position where you expect the argument to be passed. So yeah, there are variations that you can use to do those declarations. But also you can grab, out of the box, you can grab your arguments coming from other places, like from environment variables. So there's a convention. If you put a value in source_file, you will also retrieve the value. But you can adjust this. You can say, oh, actually, my environment variable name is called source, or it's called source file. You can describe what kind of transformation you want from the original option name to what should be the environment variable name. Okay. One more interesting feature that I don't think exists in other libraries is have a direct mapping between an enum type with a flag, because writing minus color red is not that nice. Writing minus red is much more simpler. So it is supported by the library, but as you can see, it's actually a bit more verbose, and there's even some repetition. Red, green, blue, those strings have to be repeated several times. This is typically the places where we would like to have some kind of macros in Unison, but there are no macros in Unison. So you have to deal with the repetition. And all of this, the fact that you're using this kind of flag in a mapping is also reflected in the help, where you will see all the different values that are accepted on the command line. Another cool thing that we can do, and we will see how it's implemented, is to repeat options. So you don't have to pass an option name just once on the command line. You can pass it several times. And in that case, we collect all the values into a list. And to do this, just put an S at the end of your declaration. And now you will parse for several values instead of just one, which I think in terms of DSL design is actually quite nice. Just put one letter and you have just the kind of behavior change that you want eventually for your parser. What I described so far was just to parse one command, but many command line applications are more complicated than this. You have several commands, and you can combine different parsers for different commands into top level commands, like in that case, a file, fs, file system command. And we use this alternative operator to say, okay, I want to parse a copy command or list command or grep command. You will find this kind of operator. If you know Haskell, you will probably feel very familiar with this kind of alternative. And then what that means is that if you run the help for the fs command, because it's a top level one, you will have the list of all the possible commands. And if you call -minus help on a specific command, you will see the help for that specific command. One last feature, and then we go to the implementation, is if you make a mistake in one argument, you type something that is almost the right thing, but not the right thing, you will be told by the command line, oh, maybe you made a mistake, try this, that should work better. Okay, so how do we implement all of this? And really the magic sauce here is to use Unison abilities. And we will see like 3 different contexts where we use this superpower given to us by Unison. But first of all, the question is, what is the data model that we use to support all those declarations? Because what we've seen so far was just declarations of things we want to do. We are very declarative, but we need to put all this information into some structured data. We have things that are almost the same, like an option, a flag, and an argument. They're almost the same, but they have small differences. Like options and flags, they have names, but not arguments. A flag has an active value. All of them can have an optional default value. So there are differences between all those things. So the way I choose to represent this was to have one data type called option. And all the differences are actually embedded in this specific thing that encodes the differences between like a pure option with a name, an argument, or a flag. But otherwise, it's almost the same data structure. So now the question is, how do we come from declarations like this, describing a flag, to a value of the type option with all the flag information? And if you remember, I said you have ability declarations, and for each ability, you need to have some handlers. But all those declarations actually come from different abilities. So there's a naming ability, providing you with support to deal with names and to declare names. But in the library, I decided to have many abilities corresponding to different aspects of what I wanted to build. So there's a flag ability and an environment ability, and so on and so forth. But eventually, we are going to grab all of this information and put it into the same object. And as a library user, you don't really have to worry about the fact that there are many abilities that we handle. They are just accessible under the same namespace, which is called DSL. So the question is, how can you write an interpreter that's going to make an option, taking some kind of effect where possibly we have some positional DSL calls, some flag calls, some repeated calls, some name DSL code calls, and so on, into this option data type that we see in the lower corner, right corner. So this is what we want to do. And that's exactly how we write it. So we go through all the cases. Okay, if you make a call to decoder, we take this information and we set the decoder option on an option value. And we do this for all the calls that you potentially make. We grab this information and we collect it into one object if you want. The thing is, it's not as straightforward as it is, because we could have some errors in doing so. Eventually, you might produce an object that is not correct. So you might say, I want a flag, but you are not giving an active value for that flag, a value that will be used if the flag is present. So this construction might fail. So we are in the case of a builder pattern, like you could find in languages like Rust or Java, where you chain methods and you say with name, with flag, with environment variables, and so on. And eventually you called with build, and that's going to build what you want and validate it at the end. So in order to do this, we actually do this in 2 steps. We first collect all the information into an intermediary data type where we don't care about the validity. We just collect information. And then there's a validate option that, depending on what you want to build, if it's a flag, an argument, or an option, it's going to validate that all the information is really there. And if it's not there, it's going to raise an exception effect using the exception ability. to tell you that that didn't work, and it's going to report it on the command line. So that's one use for abilities, for having a DSL where we purely specify what we want and then interpreting it into an object, having all the values and checking them. There's another use for that thing, which is actually interesting, because in that case we interpret an expression with all those calls, but we interpret it into the same effects with slightly different types. So when we do repeated options, when we say instead of an option, I want to parse options, I want to parse several values of that type on the command line, what we do is actually write a handler that is going to say, okay, now if you have a decoder ability, method, if you want, we are going to transform this decoder decoding just one value into a decoder that's going to decode several values. Same thing for how we're going to display the help for the value type. Instead of displaying just the normal value type, we're going to put an asterisk at the end. So what we are doing is interpreting some effects with other very similar effects with just slightly different types. So this is another use of handlers in that situation. But we are not done, because now we just have an option data type that doesn't do anything by itself. It just has a bunch of declarations for how to decode values, what kind of help we want for the option, and so on. Now we want to make a parser. So there's, again, a small language to arrange those option parsers and to be able to build commands out of other commands and so on, and to do this alternation for use this command or try to parse with this command or try to parse with this other command. And again, this is another ability called the parser ability. And this time, writing a handler for this ability might mean, okay, do the real parsing. So take some inputs, some strings, take an expression having this parser ability with all those option declarations and so on, and now do the actual parsing. And to do this, we are going to use other effects. So the parsing might fail. We might use some values from the environment, and we will need to store the state of what we have currently parsed and not parsed. So there's a state effect that is used. And eventually, what we hope to get at the end is a command that was built out of the inputs. But that's not all. So we can grab one parser expression, transform it into an actual parser, doing all the parsing. But we can take the exact same expression, this time producing the help for the command. And to do this, we define what's our target. In that case, we want to produce something from another type, command help. And we want to write another handler. And that other handler is going to take the same parser expression, the same computed expression with the parser effect. And this time it's going to produce the command help object. And to do this, it's going to go through all the cases. And every time it has some help information, it's going to produce it. This is actually not so trivial, because there's a bit of recursivity in all the calls that you can have, because commands can nest other commands, but it's doable. And to do this, again, this is handling all the cases for the parser ability. And in particular, this is where we see why it's very important for each option to give at least one example of the value of that option, like a file path, because we have those continuations K. So if we want to analyze all this expression, every time we have a continuation, we have to give it a value. But in this case, we are just producing the help. There's nothing coming from the command line. We don't have any input value. So we have to have some kind of dummy values to be able to give to this continuation, so that we can continue getting to the next declaration, in our program, and so on. Because we have those calls to source, destination, and force. But eventually we can get there and get some help. And then, I mean, once we have this help, we can transform all this help into a doc inside Unison, this doc data type that we have. But instead of displaying it as HTML, I'm using a library called Terminus, which helps people interact with the terminal. And this is where we set all the output in terms of what font should we use, what colors should we use, and so on. And this is all configurable. So there's a palette data type that you can use to change the colors. So if you don't like the colors that I'm using, you can inject other colors and you will get other colors. I think, again, this is in a way a nice testament to functional programming, where there are like different steps in your processing pipeline. And if you don't like one step, you can just change it with something else. The last thing is how this algorithm for telling people that they possibly made a mistake, how it is implemented. It was not very fancy. I think I had a look at the Rust implementation, and they were using this algorithm, which is nicely documented in a blog post. And again, this is one place where functional programming shines. Just take a formula, implement it, add some tests, and here you go. And you have to select some weights, but it gives some pretty good approximation of when something can get some better suggestions. Okay, so I know there are many things that probably went maybe a bit over your head if you haven't seen Unison or abilities or effects integrated to a language before, but I hope that gives you a good idea. I just want to recap quickly. So we started with a library with some DSLs for purely declaring what we want to parse, how we want to document the parsing, and then going step by step into transforming those declarations into some values on some data types, and then having some expressions that we can reinterpret in different ways to produce different things, either a parser, an actual parsing function, or some helps for the documentation. So this is very powerful. Now I just want to focus a bit about Unison and the experience that I had in programming this library, because it was the first time I was programming something a bit larger than what I produced before. The full library is around 8,000 lines of code. Some of those lines are kind of generated by Unison, but it's a large library. It was my first large library and large experience with it. So before I talk to you about what was good, what was not so good, I need to show you what it looks like when you're programming with Unison. So basically you have two panes. So one is your text editor, where you can grab some functions out of your database to edit them. And you say, edit this function, and it will be in your editor. And on the right side, you have a bunch of commands that you can run. So you can say, now my code on the left side is okay. I want to update it. That means push it to the database to save it, commit it. And you can run some tests, and you will have all your tests. As you can see here, all those tests that I've just executed were executed instantly because they were cached. This is one of the very nice side effects of having hashed functions inside your database. That means if we detect in Unison that an implementation didn't change, that this has no impact on your test, and if your test is pure, there's no problem. That means that your test will still pass. So that is a very cool feature. And this is basically your environment. You don't have code as file and as a bunch of files into directories and so on. Everything is into the database. And that has some nice properties, and that creates some issues. So one of them is that I found was kind of annoying was readability. So I write my code, I update it, it's in the database, and then I say I want to edit it again into a new file, a new buffer if you want. And it comes out formatted in ways that is not necessarily nice. For example, I cannot choose the column width. For example, it's 80 by default, which I personally find too small. If I add some new lines in between inside a function, those new lines will just disappear, because Unison doesn't really care about text. It just thinks about, ASTs. Text is not something that's important to Unison. So I think that's not so nice. So I personally developed a few workarounds for this, but that's not great. Also, comments are also not a thing, because comments are not really executable. So there are workarounds to add comments to your code, but it's not out of the box. Navigating code can be a bit uneasy in a way, because you cannot really click on a function and this will automatically bring you to another file containing the function you wanted, for which you wanted to see the definition. You go to the right side of the window and you say, okay, I want to view function, and it's going to fuzzy find all the functions that you can view. There's also a find command that you can use which is a bit like Google, where you can specify the type of the function. This is quite helpful, but in a way, the navigation is could be definitely improved. And if you forget to exit the fuzzy finding and you were now making some modifications to your code, all the right side of your window will be a garble like this, which is not so great. And similarly, because you have this divide in the windows, when there's a type checked error, so every time you change your code, it's type checked on the right side. And so you will see those errors accumulating, but that means that if you run a test and there's a test failure, and then you say, okay, I'm going to fix my code, then the code is type checking, maybe has some mistakes, and the failure will progressively disappear from the right side, which is not great, because now you have to scroll to see what was my failure again. Not so great. And another effect of having those windows and not having all the code available at the time is that when you update a function, that might have some ripple effects on some other functions that already exist. And their function will not be updated in the database unless everything compiles. So what Unison does in that case is that it brings all the code that needs to be modified, that has some potential conflicts, into your window, and then you fix compilation errors, but you can only fix them one at a time. And in large files, that means that you will sometimes jump between the beginning of the file to the end of the file, which is not great. That also affects performance when you have lots of code. And it's a bit error prone, because if you do this a few times, you will end up jumping around and having more code adding on top of existing code. Sometimes you just don't know where you are, what was up to date, what did you change, what was accepted, what was not accepted. That I found that a bit tricky personally on a large project like this. I must mention that refactoring records can be also annoying, because records are not really first class in Unison. They are much more like a bunch of generated functions. So for example, removing a field from a record takes a few commands. It's just not something that's just one command away. There's no notion of commit. So you say update this function, but you cannot give a message explaining why you want to update the function. All of this is coming to future Unison versions. We know about those issues, but right now you don't have this. And also, if you want to rerun your tests and check if they would break if you have a modification, you have to first update your function. So that means commit it to your database, and then you can run the test. But then if your tests are breaking, you need to, don't forget to unupdate. I mean, remove that version of the function from the database. So, I mean, you can create branches if you want to just run a quick experiment for this, but branches are not really made for that. And there's also no way to see the documentation right as you are modifying it, which is a shame, because documentation is very nice in Unison, and you need to, there are several steps necessary to display the latest version of your doc. So not great. So what I'm saying here basically is that programming with Unison would be a lot better with many more windows. So one window where you see your type check errors, one window where you see your watches or your tests, one window for the documentation, one window for searching and having a list of everything you want to search for. And in general, having more navigation actions to go from one function to another, and having some status elements on your functions. So if you modify something, you should be able to know if that thing has been committed to the database or not, and what are the repercussions right away on other pieces of the code. So all of this will make a much better IDE. So yeah, my plea to the Unison team is give us a better idea, because there's a potential to have a great idea with Unison. We are not quite there yet. But I have some good news. It's actually coming. So the Unison team is working on it. So this is, for now, they have something that is only read-only, so you can open functions, and they will open in some small cards like this, where you can see tabs with the code on one side, the documentation on the other side, so you can instantly see the modifications if you modify the documentation for a given function. So I think the future is quite nice for Unison as a programming language. And well, I think that's it for today. Please let me know if you have any questions.
Thank you very much, Eric. We had a question in the chat, from the YouTube chat.
Yep.
I love the idea of Unison as a language, but the whole development environment seems quite rigid. But you covered this in the end and said it's coming, so yeah.
Indeed, yes.
It is. How come you came into working with potions?
That's yeah. I was trying to implement. So Unison is very strong for building microservices and applications in the cloud. And one strength is that you can use Unison programs to deploy your code. No YAML files, no silliness like this. And those services will communicate together where you don't need any serialization. You just say, I want to communicate with that service, and there's no serialization involved. There's no serialization to store your data. So the cloud offering, again, is very interesting. So I started developing an application for myself to interact with my bank accounts and my accounting software.
Mm.
And I wanted to be able to pass on the command line things like my API key and stuff like that. And there was not really a way to do this. I actually started implementing in Haskell a prototype of a command line option library. So I found that the domain was interesting. So yeah.
Interesting. What are you working with day to day, Eric? I guess it's not Unison.
No, so I'm working for Occam,
Yep.
and we are using Rust and Elixir to provide some software to run secure communication using secure channels between different systems. And it's particularly useful if you have some private data that you want to put inside a query from another system, but you don't want to expose your private database or your private system to the internet. So what we offer is some kind of relay in between, where the communications go through the relay and nothing is really exposed on the internet. And we do again, we use Rust and Elixir to do this.
It sounds like a nice environment. Have you worked with more FP languages?
Oh yeah, so in my previous company, I've used Haskell a lot to do a system that was like a distributed database, if you want, using more or less a blockchain, like a distributed ledger using Haskell. And before that, I used Scala a lot. So yes.
Yep.
I'm a functional programming lover.
I hear that. Did you start with functional programming straight out of university or college?
Oh, not at all. I suffered a lot with C++ and Java for a long time before giving up and thinking that it was more than enough and I should learn Scala. Yeah, I discovered Scala in 2006 or something, and implemented one of the test libraries for Scala, and really fell in love with the language and the functional programming approach. I actually re-implemented that library twice. 3 times. And the second time was because I could not deal with concurrency. I started with lots of mutation. I didn't know how to deal with concurrent execution of tests. And I thought, oh, I need functional programming to do this properly.
Interesting. Again, thank you very much, Eric, for coming on and presenting Unison, and for always also interesting background. I think a lot of people share the frustrations with working with some Java, C++ stuff, and then finding some functional programming languages and never looking back. Yeah,
exactly.
Yes.
Cool. Thanks, everyone. Bye-bye.
Goodbye. Yes, that was Eric presenting Unison. Now we welcome Elisabeth, and dependent types are everywhere. Hello and welcome, Elisabeth. Yeah, welcome.
Thank you. Hi, everyone, and thank you to Func Prog for having me. Whenever someone is talking about functional programming, I want to join and talk about it, because what else is as fun to talk about? So, my talk today, I named dependent types are everywhere, and that is the sort of main point that I hope to get across today. And the subtitle is with application to questionnaires, which seems very random that these two things go together. But I will give you the backstory for why we are here today listening to this talk. So I work as a software developer at an insurance company, a Norwegian insurance company called Frende. And I have a PhD in dependent type theory from before that. So I was talking to my colleague one day, and he had been thinking about questionnaires because there's a lot of questionnaires at an insurance company. For instance, if you crashed your car and you need your insurance to cover it, we need information about the accident. And he was thinking, talking to me about the questionnaires that we have, and all of the questionnaire code is like super hard to read. It's spaghetti code, like it's hard to follow. Why is it so hard to write a good questionnaire? Like it seems very simple, but I don't know if anyone listening has ever tried to write a questionnaire, not just one questionnaire, but like a framework for creating questionnaires. But you think it sounds easy, but then you sit down and you try to set it up and you're like, wait a minute, how do I actually do this? And he was talking to me. Of course, I have a PhD in dependent type theory, which means I got a hammer. So that means that the problem he was asking about was a nail. I mean, it took a little while, but then I came back to him and said, yeah, you know what? This is difficult because it's actually dependently typed, but we're trying to express it in a language that doesn't have dependent types. So I'm going to try to convince you today that it's not just that I have a hammer, but this is actually a nail. So first of all, let's talk about what dependent types are. So Christopher mentioned it already, but it's probably a not well-known concept for most people. It's kind of niche. So we have in our ordinary functional programming languages some sort of dependency. So types that depend on something. So for instance, list is a type that depends on another type. So you need to say the type of elements, and then you get the type of lists with that type of elements. And depending on which type you give it as elements, you get a different type, right? So for instance, I have my list here, which is a list of integers, and it's just 1, 2, 3. But I could also have a list of bool, a list of string, and those are all different data types. And they sort of you can think of it as a function that list as a function that takes a data type as an input and then produces a new data type. And this is all well and good. We're all familiar with this. But here's a common problem that we have with lists in our usual languages. Let's say I want to grab an element from a certain index at a list, then I give it an int. But if I as a programmer need to make sure it's actually a valid index, otherwise I get an exception. I get a runtime exception that the list index was out of bounds. But with dependent types, we can actually define types that depend on values from other types, not just on types. List depends on a type. You give it a type, int, and it produces type. Okay, but with dependent types, that means that you're giving it a value, like an int or a list in my case that I will show, and that gives you a new type. So for instance, that means that we can define the type of indices in a list. So I can define a type, and this code is code that actually compiles. This is a language called Idris. It's Idris 2. There's also Idris 1. And here I define a type that takes as input a list, so a value, and it produces a type. And the type it produces is what's called in this language fin of the length of the list. And fin, if you're a mathematician, this is the type, the finite set or the finite type with a certain number of elements. And the number of elements is the length of the list. So we're programmers, we start counting at 0. That means this type contains the numbers 0, 1, 2, and so on until the length of the list -1. So here I give an actual list as input, and it produces a type that contains as many numbers as my list is long. So this type depends on the list and not on like a type, or it's not a static type like you would use for getting an element at an index. Usually you would use an int. So for instance, if I plug in my list that I defined there, I get that index of my list is the type 0, 1, 2 that contains two elements 0, 1, and 2. And this means that we can get an element from a list safely, and we cannot get an index out of bounds error. It's safe compile time. So we can define a safe get, which takes a list and it takes an index of that list. And here I want you to recognize that this index type takes the list as an argument. And then we get the element at that index. And this is safe. This is not going to give you any runtime errors, because you can the indices like that you have available depend on the list. I'm not going to go into the implementation here. It's defined in the standard library of Idris. But the point is, you can have types that vary with an argument. So this gives a lot of expressivity in the type system. So it's like turning, I mean, Christopher talked about type systems and that they're more expressive. And this is like turning expressiveness up to max. You can express basically anything you want in the type system, so in the types, which then gives you like a lot of assurances compile time, because you can express things in the types, which the compiler can then verify and check for you. As opposed to not having dependent types, then you have to do more runtime verification, as for instance, this index out of bounds problem with lists. So what does this all have to do with questionnaires? As I sort of hinted, it turns out that questionnaires are actually inherently dependently typed. So I'm going to try to explain that now. So this is a picture I made of a questionnaire, which really shows, hopefully, that a questionnaire is a graph, basically. So you have the different questions, and depending on what you answer, you might go to a different question. So this would be a small example of a questionnaire where an insurance holder has crashed a car, and we need some information. First question, did you drive the car or did someone else drive? And they can answer yes or no. I drove, I didn't drive. If they drove, then we have all of their contact information, so we don't need to ask for that, and we go directly to the last question. Where did the accident happen? Because we need to know, did it happen inside or outside Norway? And then we're done. If they said, I didn't drive, then we need some information about the driver. So we ask, what's the name? They give the name, what's their phone number? They give the phone number, and then we get to the location question. And then we're done. Okay, so a questionnaire is a graph. That's fine. Now let's think about what is the type of valid answers, like valid ways to go through this graph. Well, some examples, like you could answer yes to the first question, I drove, it happened within Norway. You could answer maybe no, I didn't drive, Hatifnat drove. This is one of our test names. And this is the phone number, and it happened outside Norway. no, someone else drove, phone number, happened within Norway, and so on. What I want to point out here is that this type of valid answers depends on the graph. So it's not, you can't define like a type of valid answers for a questionnaire statically for all questionnaires. It depends on the specific questionnaire you're looking at, and it is the type of paths that you can take through the graph. So that is inherently dependently typed. You're taking paths in a graph, and the type of paths depends on the graph, the actual graph. So that's a dependent type, and there's actually some more dependencies hiding here. So let's look at the first question again, and they answer yes or no, basically a bool. And depending on the answer, we go to different questions. So we have a function that takes a bool and returns what's the next question to go to. But over here, instead, they answer with a string. What's the name of the driver? And then given the string as the input, we say what's the next question. In this case, we go to the same question regardless, but we could have gone to different questions here, depending on what the answer was. And these two functions have different types as for the answers of the question. So we have bool and we have string. And this is a dependently typed thing. If you don't have dependent types, you're going to have to, when you say what a questionnaire is, you're going to have to somehow say once and for all what this type to the left of the arrow should be. Conceptually, maybe you don't actually write it as a function, but you need to say what kind of answer goes to what question. And this type cannot change depending on where you are in your questionnaire in a non-dependently typed language. But in a dependently typed language, this type, the bool and the string, can vary depending on where you're at. So that's very nice. And now I have implemented a framework for creating questionnaires in Idris, and the language I showed previously. And I have also implemented this specific example in my framework. And I thought that for people who are new to dependent types, it would be, the most interesting thing would be to see how does such code actually look like? Because that's what I would be wondering if I hadn't done this before. Okay, this sounds good, but like, how does such code look like? Can I read it? Like, is it insane? It's not that insane. So I'm gonna show you a couple of snippets of the actual code that does my example questionnaire here, and then I'm gonna demo and show you that this code actually runs. So this is, as I said, Idris 2. It's a dependently typed functional programming language that I used to implement this. So we're jumping into the deep end immediately. First, let's talk about the data type of questionnaires. So basically, this is the type of graphs, but with the data that we need to create specifically a questionnaire. And we define it inductively. So we're saying, okay, if you think of it in terms of graphs and nodes and leaf nodes, we're basically saying, okay, so a graph could be it could be a leaf node, and then we just need whatever data we want at the leaf node, which in my case is going to be, I want to have a full set of, I have to find a data type for the set of valid answers that I want out of this questionnaire when the user is done. And I need that. And then I also have some other data that I need for creating a model view update a model view update front end of this questionnaire. So, but that's a leaf node. As soon as we have that data, okay, we have a graph. It's a simple graph because it's just a leaf node, but it's a graph nonetheless. The other case is when you have a non-leaf node, and then I say that I want some data, again, this data contains stuff I need for creating a model view update front end of this, but also, crucially, this data, it's a record type, and it contains the, which I call answer type in this record, which is the type that the answer to this question has. So for the first question, that would be bool. For the name question, that would be string. And that is stored in here. And you usually can't, I don't know if you can, in functional programming languages without dependent types, if there are languages that allow you to have types as variables. But you can in Idris, so you can have it in the record. And then I say that, okay, I need also a function that, given an answer, so an element of the answer type, you need to say which question to go to next. So a function from the answer type to the type of questionnaires. So you're pointing out another graph, basically. And this could be a leaf node, but it could also be another non-leaf node. And this is where we have this dependent type. So the type to the left of the arrow here depends on the data that you had previously, and it varies. And then that gives you a non-leaf node. So concretely, in my specific example, the first question is the question, did you drive? And it takes the next question function, takes a bool, and returns which question I should go to next. If you answer true, I drove. We go immediately to the location question, and we know that the person who drove is the insurance holder. If it's false, then we go on to the name question. So we can actually use the type here. We can pattern match on the elements of the type here to go to the correct question. For the name question, instead we take a name and say what question to go to. Name here is actually not just a string, because we're in a dependently typed language, and that means that we can actually put constraints on our types on the type. So in this case, name is an alias for a non-empty string. So I have the constraint in the type that it should be non-empty. And here I say that whatever name you get, we go to the phone number question. And again, I want to point out that the type to the left of the arrow here varies depending on which question we're at. And we can do this because we have dependent types. Some more fun stuff from the code. I defined the type of phone numbers with constraints so that we can only have valid Norwegian phone numbers. So a phone number consists of digits in a Norwegian number without the country code. It's 8 digits. And a digit, of course, it's not just any character. It's actually a number from 0 to 9. So it's an element of fin 10. If you recall, that's 0 to 10 minus 1. So 0 to 9. So we need digits, that's those. And then I also have a type that I call isValid number, which takes a 8 long vector of digits and says that it's a valid number, which means for a Norwegian number that it starts either with 4 or with 9. And here, I want to point out the head of number equals 4 and the head of number equals 9. These are now types. Usually, one uses like the double equals sign in most languages, which gives you a bool. But that's a value. And this function is returning a type. So these two things, head of number equals 4 and head of number equals 9, are actually types. And the way you can think about these types is that they could be empty if head of number is equal to 3 or something. It's not actually equal to 4 or 9. Then both of these types will be empty. But if the head of number equals 4, if it's 4, then the left type, the head of number equals 4 type, will contain an element, which is basically a proof that the head of number equals 4. This is a lot to wrap one's head around, and there's actually an entire branch of dependent type theory called homotopy type theory that sort of builds out from thinking about this type. So if you're confused, don't worry, like it's a whole field of research. But you can do this in the type system, so you can put this constraint in the type system, which means that you have this constraint compile time. So then I define my mobile phone number type, and I say it's a vector of 8 digits, and that this vector should be a valid number, meaning the head should be either 4 or 9. And this is the Idris, these two asterisks. That's just the Idris syntax for a tuple, where the type of the second value can depend on the first value. In this case, it does depend on the first value. So my mobile phone number, I know is going to be an 8-long vector of digits, and the first is either 4 or 9. And this is compile time. So I don't have to, as a programmer, just remember every time I create a mobile phone number. If you had like just I don't know, a list of int or something in a non-dependently typed language as your type of phone numbers, then you would have to always remember whenever you're creating a phone number to check that it's a valid number like this. And I mean, you can make it private and have only be able to create it through something that checks this, which is works fine, but it's possible to represent phone numbers in your type that are invalid. Here, it's impossible to represent them in the type. This type only contains valid numbers. So that's kind of cool. I still, of course, when the user gives their number, it's going to be as a string. So I still need to try to parse this string into a valid phone number. And that parsing could fail, it could be invalid, but then I need to do something to get the user to try again or fail in some way. But the thing is, I cannot forget it. I have to do it. My code won't compile unless I have implemented some way to get a valid phone number from user input, usually by trying until I get something valid. And then finally, I want to point out something that I realized, another dependency that I realized when I was going to implement this with a model view update web frontend. So I was going to do a model view update frontend with Idris, and Idris compiles to JavaScript. So there are libraries for model view update that compiles to JavaScript. It's very nice. And then I came there and I was like, what should the event type be? What should the state type be? And I realized that the event type is actually a dependent type. It should depend on the state type, right? So I don't know how many of you have used model view update before, but you have a state and you have a type of events, and usually they're separate, completely separate. So you have your type of states, your type of events, and then you need to have an update function that takes a state and an event and gives you a new state, and you have a view function. The thing is, when these are separate, then you need to handle every combination of state and event in your update and display function. But if you think about it, in most cases, your event type, like not all events happen at every state. They differ. So for instance, in my questionnaire, at the first question, I have an event for the user when they answer yes, I draw, and an event when they answer no. But on the second question, I just have a submit button and a text field for writing the name, and those are different events. And it doesn't make sense to have a yes/no event at the name input question. And similarly, It doesn't make sense to have like a text input event at the first question. That's just yes or no. So the event type should depend on the state type. It should change depending on what the state is. So, of course, I had to fix this. So I took the library, the Idris DOM MVC library, it's called, and I forked it and I changed it so that the event type depends on the state type. And then I implemented using that. So here I have implemented the event. This is the event type for the for the thing that runs a specific questionnaire. So it's not the specific questionnaire of my example, but this is a general like MVC that runs the whole thing. And this is the event type. So first in this library, we have an init event that is run the first thing that happens. So we just need that, but it's not interesting. It doesn't contain anything. So it's just the unit. And then I say, okay, when we're at the last question, so the leaf at the end, the leaf node, there are no events there. If this was an actual questionnaire we were using, we would probably like submit the answers somewhere. But in this case, I haven't implemented anything like that, so there's nothing there. And then here, this is the interesting event type. So when you're at a non-leaf node, so a question that continues somewhere, then either it could be like a local event. So every question has its own event type and its own like update and display that does stuff when you're not finished with an answer, but the user is interacting with the question, but staying within that question. So it could be either an event of that question, or we could get an answer to that question, in which case we will be moving on to the next question. Okay, so the event type here depends on the state, which means that, again, I get more guarantees compile time. I know that any combination of state and event will only be a combination that actually will happen and that actually makes sense. So a lot of talking, a lot of showing code. Does this actually work? It does, and I will demonstrate that now. So here is the questionnaire for the graph I showed. So it starts with, did you drive the car? Yes, I did. Where did it happen? Let's say within Norway. And then here on the last question, I'm just displaying the data that we would then be sending off somewhere. Let's say, okay, I did not drive the car. Nope. What's my name? Or the name of the driver. Let's just say my name here. And I submit. And then I get to the phone number question. And does this work? Nope. I have to give a valid phone number. Okay, let's try 8 digits. And remove that one. 8 digits. Nope, doesn't work because the first one isn't 4 or 9. So let's try with 9. Yay. And then, yeah, let's say it happened outside Norway. And then this is the thing I end up with. So all of my talk actually works in a questionnaire. And this is interesting. My keynote stopped working. There we go. Okay. And let's keep going. So, takeaway. What is my point with all of this? Well, hopefully, maybe I convinced you that dependent types are everywhere. So what I mean by that is like if you think about the abstract structure, don't think about like how should I write this in a programming language, but like the data structure abstractly. There are a lot of structures that are actually dependently typed where the type should change depending on the value. But of course, that's not how we live in our everyday life. We live with programming languages without dependent types, which is totally fine and like useful and works in a lot of cases. But the thing that happens then, if you have a structure such as a questionnaire that is actually dependently typed, like abstractly, then when you're implementing it in a language that doesn't have dependent types, you're sort of translating a dependently typed structure into trying to express a dependently typed structure in a language that doesn't have dependent types, which you can do, but it puts more on the programmer that you need to verify and validate stuff runtime, and you're not going to be able to represent the structure in your type system completely. So with dependent types, the languages which have dependent types are extremely expressive. You can express like anything you want basically in the types. But of course, the downside is it becomes more complex. The type checking, the compiling is more complex. So it's like you need to get used to this way of programming, and you can get more like difficult to understand errors and unification issues and stuff like that. So, I mean, I have a PhD in dependent type theory, but I wouldn't say dependent types is the end all be all and we should be using it all the time for everything. But it gives more security assurances compile time. So to me, it makes sense that we could use dependent types for very security critical parts of software, not even maybe the whole software, but like the most secure critical parts of software. And then we could use non-dependent types for other stuff. And dependent types are also used for verifying mathematical theorems. And I didn't talk at all about this today, but that's what I did my whole PhD. But because you can express anything in your type system, you can actually express mathematical theorems in your types. And that's a whole other area, but it's super fun. And if you're a mathematician, I definitely recommend you trying to prove something in a proof assistant, which is a proof assistant is the dependently typed functional programming language, basically. And it's coming soon to a Haskell near you. Dependent types are on their way into Haskell. It's a company called Seroquel, and they claim that they're adding dependent types to the GHC compiler, but they have been working on it for several years now. I don't know exactly when they started, and it might take several more years before they're done because the GHC compiler is super complex. We have all of these language extensions. So retrofitting dependent types on top of that becomes very complex. So it can take a while, but it's on its way. If you want to try it yourself today, I would recommend doing that if you think this sounds interesting. Then you could use the language I used called Idris 2. I would say that this is the most the dependently typed language that is most oriented towards writing executables, basically. Which might sound weird. What do you do if you don't write executables? But what you do if you don't write executables is that you use it as a proof assistant, and you verify your mathematical theorems by just type checking your code. Then you also have a popular one called Lean 4. That's the most recent rendition. This one is, I would say, more geared towards being a proof assistant, but it can do executables. But if you want to try formalization of mathematical theorems, I would probably start with Lean 4. It has a large library of mathematical proofs. But you can also do executables with it, and it's very easy to get started with because it's developed by Microsoft, so it has support for VS Code. So you just install the extension in VS Code, and then bam, you're good to go. So that's nice. You can also try Agda. there's, like Idris, very Haskell-like and has dependent types, but it also leans more, I would say, towards being a proof assistant, but you can write executables with it. And then we also have Rock, this recently changed name. The new name of this language is called Rock, and it's also, I would say, more geared towards being a proof assistant, but you can write executables with it. Yeah, I think that's it for me. Thank you so much for listening.
Thank you very much, Elisabeth. Thank you. I will start with questions immediately from the chat. Is the phone number validation at runtime the same as at compile time? That is it using the type definition at runtime?
So the validation, I have written a function that tries to validate a string into a phone number, and it cannot produce a value unless it's a valid value. So, I mean, it checks that, first of all, it checks that it's an 8-long string of, well, all the characters are digits, and then it checks that the first digit is 4 or 9. So, yeah, I don't know exactly. I mean, it's checking this thing runtime, but and it cannot produce anything that would be invalid in the type.
Thank you. Next question. Is there this example available somewhere, like on GitHub, your personal blog?
Yeah, so it's available on my GitHub. I do believe that the repository is public, but I haven't posted the link anywhere, but I can do that. It's very much a work in progress though, so just beware. And also you need to, for this to compile, you need to use my fork of the DOM MVC library where I changed the event type to be dependent. But I can post a link to this GitHub. It's on my GitHub.
Yeah, please do, and we'll post also the link below in the comments or in the description later here in YouTube also, so people can find it afterwards. How come you got into doing a PhD in dependent types? This seems like an odd thing.
That's kind of niche.
Yes.
Yeah. So my background is in abstract mathematics. I did a master's in mathematics, and I liked the abstract part of mathematics. And then I was doing it at Stockholm University. And there's a lot of dependent type theorists at Stockholm University. So I didn't know what type theory was, but I just sort of heard some, I don't know, by osmosis, I realized that you could use, with type theory, you could use computers to verify your mathematical proofs. And I always loved the programming courses that I took. So I was like, oh, yes, this is like the best thing of two worlds. And then when it came time to decide the project for my master's thesis, I was like, let's do type theory, although I knew nothing about it, but it just sounded fun. And then I learned dependent type theory from there for my master's thesis. And then when I was done with my master's, there was this PhD in dependent type theory, that PhD position that showed up here in Bergen. And I was like, yeah, I want to keep doing this for 4 more years. So, yeah.
Interesting. What are you doing today? Are you working with Idris or are you working with something else?
Yeah, so I'm a software developer at an insurance company, and I don't get to work with dependent types, but I get to work with functional programming. So I do F#.
Nice.
Yeah, I would love to do Haskell, but I mean, F# is better than C#.
Yes, yes. I usually give everyone the same advice. If you want to work with Haskell, you should start your own startup that uses Haskell. That's the best way to work with Haskell. Yeah. Thank you again. Thank you very much, Elisabeth. Yeah.
Thank you.
Yes. And with that, thank you everyone for watching tonight, and thanks for all the nice sharing in the chat and all the nice questions. Please do remember to follow us on YouTube, check us out on MeetUp, and also check out the new podcast we're doing. And if you want some specific people to come on, either to the MeetUp or to the podcast, please reach out to us and ping us or use the chat in Discord to suggest people to come on, and we'll try to reach out to them and see if they want to come on and either present or partake in the podcast. With that, thank you everyone again, and have a nice evening, day, morning, lunch, wherever you are in the world. Bye.